Hello everyone, in this Thierry Sicard tutorial number 30, we will review the life of Coulomb, the torsion balance he developed to measure the electrostatic forces and find the Coulomb's law. Before to speak about the Coulomb's law, I would like to spend some time to talk about Coulomb's life. Charles-Augustin de Coulomb is born in 1736 in Angoulême. He went to Paris at the École Royale du Génie de Mézières in 1760. In 1761, he was graduated and joined the French army as an engineer in the rank of lieutenant. Coulomb was involved in fortification and soil mechanics. In February 1764, a young engineer of 28 years old is sent to the Martinique. At this time, it was a long travel of 2 months to cross the Atlantic Ocean. This trip was already an adventure by itself, not as today with few hours of commercial jet. He was sent to the Martinique to be in charge of building the new Fort Bourbon called Fort de France with more than 1,000 workers. This task occupied him up to 1772, means 8 years. Then he returned to France at the rank of captain and was sent to Bouchain. However, he began to write important works on applied mechanics and he presented his works to the Académie des Sciences in Paris in 1773. In 1779, Coulomb was sent to Rochefort to collaborate with the Marquis of Montalembert to work on fortification on the Île d'Aix. In 1789, due to the French Revolution, he resigned his appointment as Intendant des Eaux and Fontaines of Paris, and he decided to stay in his property in Blois. He did a smart choice because he was a noble, and during the French Revolution a lot of nobles was sent to the guillotine as the famous Lavoisier, and plenty of other scientists and mathematicians. I think due to this smart choice, Coulomb avoided the guillotine. The revolutionary government worked on the metric system. For this reason, they asked Coulomb to come back in Paris to work on the new determination of weight and measures. In 1802, he became one of the first members of the French National Institute. Coulomb died in Paris in 1806, so 6 years after Volta presented his battery. Following this short review of the Coulomb's life as a young engineer, we will explain his experiment to measure the electrostatic forces. After doing fortification and soil mechanics, he decided to work on something he could manage by himself, so he started to build the torsion balance to measure the small electrostatic forces. In 1784, his memoir about the theoretical research and experimentation on torsion and elasticity of metal wire appeared. He used a silver wire with a diameter of 0.03 mm and a length of 76 cm. This silver wire is attached on top on the moving part to adjust the angle. The bottom line is attached to an horizontal steel rod of 24 cm with an aero brake on one side to dump the oscillation. Then Coulomb started to do a characterization of its torsion balance. He found that the torque was proportional to the angle, proportional to the fourth power of the wire diameter, and inversely proportional to the wire length. So, for a given wire diameter and length, the torque, or moment, is equal to C alpha, where C is the torsion constant and alpha the angle. If the horizontal rod turns of an alpha angle, the moment of the force is equal to F times OH, with F orthogonal to OH. OH equal L cosinus alpha over 2. The system is balanced when both torque C alpha and FL cosinus alpha over 2 are equal. After its torsion balance characterization in 1784, Coulomb started its first experiment in 1785. The first experiment is as follows. He brings a small sphere electrically charged close to another one uncharged. He measures the horizontal rod angle of alpha and he turns the vertical wire of beta prime to get another angle alpha prime with the horizontal rod. When the red sphere touches the black one, the electric charge Q are spread on both spheres, and he measures alpha equals 36 degrees and he gets the first equation. Then he turns the top of vertical wire of 126 degrees to get alpha prime equal 18 degrees and he gets a second equation. Doing the ratio of both equations, he found that alpha prime plus beta prime over alpha means 144 divided by 36 was equal to 4, and then f prime over f was equal to 3.88. The ratio r over r prime equal 1.98. So the square of r over r prime equal 3.92. Coulomb concluded that the ratio of forces was almost proportional to the square of the distance. As 98 years earlier, Newton found the attraction forces between both masses was g m1 m2 divided by r square, Coulomb stated that the electric forces were proportional to the inverse of the square of the distance. Coulomb, for its second experiment, starts as the first one by measuring the alpha angle for both spheres with Q electric charge. Then he takes another uncharged sphere to spread the charge and get only half charge. Now he turns the top of the vertical wire of beta angle to get the same alpha angle and get a second equation. As beta angle equal alpha over 2, both equation ratio gives f prime over f equal 1 over 2, means f prime equal f over 2. So f is proportional to the electric charge. In fact, after all the knowledge on electrostatic experiment by rubbing amber and attract light element, Coulomb is the first to write a mathematical equation F equal K Q prime over R square, allowing to calculate the electrostatic forces. To simplify the equation as much as possible, on the electrostatic unit system, the K factor was set to 1. So the formula became very simple as F equal Q prime over R square. I want to thank you for your attention. On my next Thierry Sicard tutorial number 31, we will talk about the Gauss theorem regarding the electric field. So see you soon and stay tuned.